Hi, Henk Akkermans here, Supply Network Dynamics Chapter 3, Part 5. Some bathtub dynamics with global warming. This is an example from the website of John Sturman at MIT. And let me switch to that one now straight away. Bathtub dynamics and climate change. And John has played an important role in his models, in particular in sculpting and supporting the effect-based debate on greenhouse gas emissions. And this is a little toy, but a very instructive toy that he has developed to explain some of the complexities involved. I won't go through the entire story for you because it is a complex story. So let's not do this one. Let's go to the experiment straight away. My main purpose in this example is to show you how difficult feedback is. So there are more experiments, and you're extremely encouraged to study this and to play a lot more with this. But in my case, it's about the bathtub dynamics. So what we have here, we start off in 1900. This is the amount of greenhouse of CO2 in the atmosphere. Of course, gradually, the greenhouse, the CO2 is taken out of the atmosphere. But we add a lot more. Initially, nothing much in particular, but more and more over time. So if I do almost nothing here, then you see that the blue line stays almost flat. In other words, the CO2 concentration in the atmosphere doesn't grow at all, which is very nice, but not what happened. What happened was the blue dotted line up here. Some kind of, and what we want from, say, up here onwards, so 2013 we are, as I recorded, that gradually we get a leveling off of this level. And how do you do that then? Okay, so we'll have to crank up the CO2 in the atmosphere. This is, I suppose, gigaton of CO2 per year. We have to crank it up and then smooth it back again. Let's see if I can do that. Okay, there we go. Yeah, I have to. More. Oh, I'm too late. Oh, more. No. No, that's just not what happened. And still I overshot. So let's see if I can do better. I probably have to crank it up a bit more in the beginning. There we go. Oh, that's too much. Whoop. Yeah, and now more. Okay, now I have to get back again. Oh, no. Okay, try it one more time. There we go. Yeah, come on, Henk. You're the professor. Up, more up, down. Oh, too much. Anyway. And this is a very simplified situation. If you have a saturation in the sink, for instance, which you could, so that after a while this sink is saturated, as it says, so the atmosphere that there is less being taken out, it becomes, there is quite some debate on whether or not that's the case, then it becomes even more difficult to scale back, although I'm actually doing better. Is this the easier scenario then? Well, again, unexpected behavior. So this is pretty good, isn't it? But then again, if you look at CO2 emissions, this sounds pretty, well, I don't know. And with positive feedbacks, don't know what that is, but usually positive feedbacks make things worse. Probably is that the more you have in the atmosphere, the more you get in the atmosphere. Hey. Yeah, but I had a cut of 73% there. That's just not logical. Anyway, so the main point of this exercise is to show how difficult it is to have, if there is some time delay between the actions that you take and the implementation of those actions, to actually keep something in control. Actually controlling your bicycle is a lot easier once you get to know it, and first you have to learn.